Genes associated with autism. Understanding the genetic basis of autism spectrum disorder or ASD. First, let's talk about the brief definition of autism spectrum disorder, or also known as ASD. What is autism? Autism, also referred to as autism spectrum disorder, constitutes a diverse group of conditions related to development of the brain. For about 1 in 100 children has autism. Characteristics may be detected in early childhood, but autism is often not diagnosed until much later. The abilities and needs of autistic people can vary and can evolve over time. While some people with autism can live independently, others have severe disabilities and require lifelong care and support. Next is genetic and autism. Genetic factors are estimated to contribute 40 to 80% of ASD risk. The risk from gene variants combined with environmental risk factors such as parental age, birth complications, and others that have not been identified determine an individual's risk of developing this complex condition. Although scientists are still trying to understand why some people develop autism and others don't, risk factors may include: first, a sibling with autism; second, older parents; third, certain genetic conditions such as Down, Fragile X, and Rett syndromes; and lastly, a very low birth weight. Next is genetic basis of autism. For other children, genetic changes or mutations may increase the risk of autism spectrum disorder. Still, other genes may affect the brain development or the way that brain cells communicate, or they may determine the severity of symptoms. Some genetic mutations seem to be inherited, while others occur spontaneously. Identified genes. Some of the other genes in which rare mutations are associated with ASD, often with other signs and symptoms, are ARID1B, ASH1L, CHD2, CHD8, DYRK1A, POGZ, SHANK3, and SANGAP1. In most individuals with ASD caused by rare gene mutations, the mutations occur in only a single gene. Next is rare genetic mutations. A recent study identified an excess of inherited protein truncating and missense variation in constrained genes in multiplex families. Rare inherited variants, missense, and protein truncating variant, or PTV, together account for up to 6% of the total likelihood of autism. Next would be twins and family studies. Ever since the twin study of Bailey et al. Reported a concordance rate for autism of 60% for genetically identical monozygotic or MZ twins and 0% for dizygotic or DZ twins, autism has been perceived as a strongly genetic disorder. So in conclusion, autism spectrum disorder or ASD has a complex genetic basis, both inherited and spontaneous mutations contribute to ASD risk. Identified genes play crucial roles in neurodevelopment. Common and rare genetic variants impact autism susceptibility. environmental factors interact with genetic predispositions, advances in genetic research have shed light on the intricacies of ASD. So that will be all. Thank you.